class, this is Miss H. At this point, you should have watched the introduction video and placed your response. Now we're going to go ahead and get into the notes. So our first question of the notes is, how is acceleration defined? And if you notice, I have compressed the notes or condensed them so that they're not as much. You should be writing these all by hand, and then whenever you're done, you can just lay them flat against a surface and then take a photo either with your Chromebook or with your phone, and you can upload that to the Google Slides. That way your notes are, and by the Google Slides I mean your IPC notebook. That way all of your notes are in one location and you can reference them easily. So now to go ahead and get into the notes, how is acceleration defined? So it is the rate at which velocity changes, and its formula can be seen below. Acceleration is equal to v sub f minus v sub I divided by t. So this A stands for acceleration, is equal to final velocity minus initial velocity, all divided by time. So what is A? The variable A represents acceleration. What is v sub f, and how do you say it? So the variable v sub f is pronounced v sub f and represents the final velocity. So that sub f means that the f is a subscript. So we have a big V and then we have a subscript f to let us know that it's the final velocity. What is v sub I, and how do you say it? The variable v sub I is pronounced v sub I and represents the initial velocity. So again, that little I, that subscript, stands for initial, so initial velocity. What is t? The variable t represents time. So now how do I use the variables above to calculate acceleration? We have one example. A car is at rest. And let's follow the steps whenever we solve this problem. So we're going to follow these steps as we solve the problem. We're going to box all the numbers and underline our keywords. So whenever I say a car is at rest, in physics, if anything is at rest, that is very important. Then it accelerates to 45 kilometers per second over the course of 5 seconds. So we box those two. What was the average acceleration? So I'm going to underline that part. Alright, now that we have all of our numbers boxed and our keywords underlined, we're going to go ahead and move on to step number 2. Assign each number in the problem to a variable. So first things first, I said that being at rest was a very important number. Was a very important word because it actually represents a number. So if we're at rest, how fast is the car going? It is going 0 kilometers per second. I chose kilometers per second because that's what it's expressed as earlier. So it's going 0, right? 0, any speed measurement. We'll say 0 kilometers per second, and that's a velocity. So is it the final velocity or is it the initial velocity? So that is going to be our initial velocity because we're starting at rest. Then we accelerate. So we're going to have 0 kilometers per second. And now we look at our next given. It's 45 kilometers per second. So if it's kilometers per second, I know it's a velocity. And we've already filled in our initial velocity, so it must be our final velocity, 45 kilometers per second. Then it says that this happens over the course of 5 seconds. So which variable is our 5 going to be? It's going to be our time. And that makes sense because seconds is a unit of time. Now whenever it comes time to do the problem, step number 3, substitute those values into the equation. So I'm just going to put another equal sign. V sub f is 45 kilometers per second. Then we have a minus sign. V sub I is 0 kilometers per second. And whenever I do this on a calculator, I'm going to put that in parentheses. You'll have the Desmos calculator provided in your links for this assignment. And then we're going to divide that by our time, which was 5 seconds. So I'm just going to write a little s for seconds. Now, let me go ahead and pull out a calculator. So the parentheses at the top mean that I have to do the top operation first. So you guys will use Desmos and you can type in the parentheses. I don't have that to show you physically, so I'm just going to do it on my phone. 45 minus 0 still gives you 45. Then if we divide by 5, we get 9. So that's going to be equals 9 kilometers per second squared. Alright, and now you will write your summary. So for your summary, I want you guys to use these sentence stems today. Today I learned, and then you're going to say, first I, and then for your next sentence you're going to say, then I, and you can write next I, and then if you have one more step, you're going to write finally I, and you should be sure to include all of your steps in your notes. So key part, we're actually going to take out distance, displacement, time, and speed. You can use velocity, acceleration. We're going to take out graph. So you're only going to use velocity and acceleration. Oh wait, actually, keep time. Alright, so velocity, acceleration, time, and also, that's it. Okay, those are the words that